really might be a possibility that we could just, needle on one end, tube in between, needle on the other end. Couple different ways that we could do that. But, so before we dive in, no extra reminders, homework, we're just plodding along. Next week is going to be all 3 twos. We plan on taking the Chapter 3 Mastery right before Discovery Day. If you guys have not been told by 8th grade teachers, Wednesday is the end of quarter 1 grading. So not that it is the end of quarter 1, but as you guys probably remember from last year, I never want to assume anything because last year was so broken. We cut off grading a week and a half to 2 weeks before the end of the quarter to give you time to get everything mastered. No one in here has any issues for me, at least as of now, so that is not a concern for math, and highly doubt it will be a concern. So to refocus on this problem, yeah.
Just a quick question. Are you going to grade the math 2?
Masteries? Yeah, you should get those back tomorrow, hopefully.
So will it go for quarter 2 or?
Quarter 1. Because, yeah, it's still, we took it during quarter 1. I'm giving it back to you during quarter 1. Yeah. So, here, what I needed to clarify is we're saying if we don't know anybody's blood type, and we're completely guessing, what are, who's the sick one? Nick or Zach? Zach. What are the chances that Zach will survive? So what we really need to do is look at all the boxes that would make him survive, and all the boxes that would, cause his demise.
Would it, a blood transfusion? Oh, is he, dying anyway?
He needs a blood transfusion. He has been bitten by something or whatever. I forget what they say.
Losing blood rapidly.
Yes, Nick is injured.
Zach has been injured and is losing blood rapidly.
So the problem is you can't just dump that blood back in, right? Like lots of kids think you can drink blood and it goes back into your body when you get a cut. Yeah, that does not happen, right? We know that because we're smart people.
Do you get your nutrients, like iron back?
It gets digested. So
I don't think that would be too good for you.
Steak juice, you're getting iron, and that's blood.
Steak juice?
Steak juice, also known as blood.
So let's say good and bad, right? So we said, in this premise, O can donate to everybody. So if Nick is O, Zach's good either way, right?
Yeah. Or if Zach is AB.
What do you mean? Or if Zach is AB?
Because anything can do AB. Yeah.
Or if Zach, he himself is AB, so down here?
Yeah.
Okay.
Or if both of them are A and both of them are B. Or those works too.
Yeah, A could go to A, B could go to B. It might be easier to calculate what's his chance of death.
And if both of them are AB too.
And if both...
Oh, we
already got that one. AB cannot... And guys, remember, this is a simplified pretense. If you actually want to become a phlebotomist, the person that draws blood and stuff, this is way oversimplified. According to this premise, though, AB can receive from A or B or O, but can AB give to anybody?
No. Only AB.
Only AB. So, but actually, according to this model, do they tell us if A is allowed? Okay, yeah. Well, a donor with type A blood can donate to a receiver with A or AB, so they should have kind of...
And same thing for O.
We need a little loop.
And O should also have a loop.
And AB.
So if we really want our diagram to be correct, now we have that. So we need to go back up here and add what?
Little X's on the other one.
Have we got all the safe spots? I mean, we can...
If one's A,
I guess we
the
can
other's
figure
B.
out. So A cannot donate to O, right?
No.
Yeah. Bad.
B can't donate to O.
I'm just not going to mark the X's if we decide and just mark the...
A cannot donate to B, but A can donate to AB. And B can donate to AB.
Oh, yeah. So AB... Wait.
AB can donate to AB. We got that one.
Oh.
Yeah, but A and B can both
No.
go to AB.
Yeah, all of the...
We got A going to AB
Oh,
and B
yeah,
going
we
to
did.
AB.
Oh, yeah. So they're all good except...
So these are bad? Because that's AB trying to donate to A and AB trying to donate to B, which it can't.
Well, it can. It just...
So
Well,
once you die,
AB blood can only donate to AB.
What would happen if you just, got
you die.
You like
And your body rejects it, and it's not good.
It just doesn't do anything, or does it like?
So imagine putting water in your veins.
Oh.
If your body can't process it as blood, if it does not agree with your body, it is like a foreign material in your veins, right? So it's like they're not compatible. If you ever dump oil in water and they just don't mix,
Ooh, if you put lime juice on a slice of provolone cheese, that also happens.
who, why, what, where, how? No, just no.
Mac and cheese is a liquid.
So, all right. So like to get the probability of this death box.
A times O. Probability of A.
So 0.4 times 0.45.
Yeah.
Yeah. Does anyone have a calculator?
I sure do.
Point 18, y divided point 18.
Of
Is
course.
there any way to like lump these together? I'm just asking the question because I don't know.
You can multiply.
Yeah, you could. You could add up A plus B plus AB and then multiply it by O.
Could you?
Will it work? You want to test it?
I think it should.
So 0.51, 0.5. I think that'd be 0.55 then together. Oh yeah, because 45%. So this section is 55%. But 45% of 55%.
Oh yeah, it does.
0.2475.
And we don't need to know the.
Now let's double check it though. We got 18% from over here. Let's do 0.11 times 0.45, like 11% times 45.
Okay.
What'd you get there?
Point 0495.
And now 4% times 45%.
0.016.
Ooh, wait.
Wait, what?
18 plus
Point
about 5 plus 1.5.
Oh,
I
shoot.
got
I did that wrong.
0.018.
Which one is wrong?
0.018.
This
Yeah,
is 0.18.
0.018.
So is that right?
0.01.
20. This will give us like 23, 24. Yeah, I think that works.
Wait, what's 11? 0.0495.
Yeah, this would be our middle death box here.
Oh.
Right, and then 0.018. Sorry, a little sloppy. So I guess right here, if we want to take that shortcut method, 11% plus 4%, 15% times 40%.
0.06.
And then here, is there a way to shortcut?
Yeah.
40 plus 4.
Yeah, so 44% times 11%, right?
No, times 11%.
What'd you get?
Hold on. 0.484. Or 0.0484.
So these two together are like 30.75%. Excuse me, so approximately like 35%.
Chance of dying.
Yeah, so I mean, 65% chance of just getting lucky.
It's 35.59. Exact.
Okay.
That's not terrible.
It's not terrible, right?
Is that dying? Oh yeah, that's dying.
Yeah, so I mean like 36% chance of dying, like 64% chance
So
of
it's
getting
like-
lucky and living.
It's like 2/3.
Like.
Now, what if... Actually, I think I say too much sometimes. I think I just want to show us our next situation. So we've got two spinners. So your teacher challenges... Well, so your teacher, right? Let's talk about me in the third person. I challenge you to a game. We're going to spin both spinners with probabilities listed, as we can see. Probabilities? I don't see probabilities listed. We'll come back to that. First letter comes from spinner 1, second letter comes from spinner 2. The letters form a 2-letter English word. Great, now language, arts, and math. Who does that? You win. Otherwise, I win. Mahaha.
Why does CPM insist on
So wait,
words?
if you get the letter U, you're screwed.
No. You've never heard of the word two?
You've never
Oh,
heard
that's
the word
Spanish.
up or ut?
Oh, I forgot. It said English. I was like,
Okay, so wait, you said if you get the letter U, you're screwed. So, what's the probability of getting U?
Well, we don't know
It's
that.
1/6.
Yeah, we do.
It's 1/6.
How do you know
I don't
that?
know what that. Because 60 is a sixth of 360.
Ah, the degrees tell us the chance of happening.
I use 2/6.
So then A is, what'd you say?
2/6.
How do you know that?
Because it's 180 minus 60.
Yeah, if things look to be straight, they are straight, so we know that would be
That
like a
means
diameter.
it's a diameter. Yeah.
So then I would be,
3/6.
yeah, 3/6 or 1/2. So then T over here,
Is 1/4.
1/4. And then this is, so I want you guys to determine who's got a better chance here, you or me.
So we got if, we got af, we got at, and we got it. So the I is just
Wait,
a
af
guaranteed
is
one.
not a real word.
Yeah, that's our only problem.
It's the beginning of the word
We have
Afghan.
it, at, and if.
I love wearing an Afghan.
What is an Afghan?
It's like a,
Wait,
like a,
isn't that the name
like a-
of someone from Afghanistan?
no, that's an Afghani, I'm pretty sure. But an
Oh.
Afghan is like a blanket.
Wow. Huh. I'm gonna go up to the board.
Does spinner 1 impact spinner 2?
Yes. No.
Yeah, not unless there's some magic, right?
No.
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 And what
No.
is left? That one's the one we need to figure out because that's just a 50% chance for that one. And then times 1/4. It's 1/3 times
Oh, yeah.
1/4. We just need to calculate. That's
Wait, where'd the 1/2 come from?
This
Because
side.
if you get the I, you're good. Because it works with either.
Oh, because it and if are, so spinner 2 doesn't matter then is what you're saying.
If you get the I, yeah. So you got 50%
Or
chance.
if you get the A, it only works with that, so it's 1/3 times 1/4.
So plus 12.
And then you said U is
7
just
12.
bad.
Yeah,
Yeah.
U is just no.
Unless I is a word.
It's not.
If we double the
It's
T,
not.
it's tight.
Which I don't think is
Which
a word
obviously
Actually,
was a
it's a
king and is very important, right?
Yeah.
either. Yeah, but that wasn't.
Okay, so what is
Whole
1/3
time.
times 1/4?
Uh-huh.
It's a 12.
So what are we
It's
saying is the
7/12.
answer here?
It's 7/12.
7/12. So who's got the advantage?
Us.
Okay.
By 1/12.
You really think so?
Huge
Let's
advantage.
try. Hold on.
I think so.
Alrighty.
Are you
Hold
gonna
on.
multiply 1/3 by 1/4 in your calculation?
Times 1.
Dude, you know that that's right.
Times.
What are we doing today? What is today's
Wait, is
lesson?
it 1/2 plus or 1/2 times?
Oh shoot.
Is it plus? It's plus, right?
Yeah.
Yeah. Okay.
Plus 1/3.
All right, grab a seat. Let's see what happens.
Oh.
Let's do this 12 times, right?
No, that is not good.
Ah! Nope, I
Wait,
win.
I need to mark this. Give me 1 second.
You should just write down the words that we make. So we made af.
Here, Connor can make them.
Oh, right. Okay.
If.
Yay!
We got one. Now we're tied.
Oh.
Af.
I feel like AF is rigged. AF-OP.
If.
Yay!
Tied. If.
Yay!
Seems like if is going to come up more than anything else.
Yeah.
Af.
Oh.
If and af.
It hasn't landed on T.
Well, I mean, if and af seem to be the most probable, right? Af.
Oh.
Af.
Oh.
If.
Yay!
I think I'm up by 1, right?
This is
Yeah.
This is so. If.
Yay!
It.
Yay!
Ooh.
We should have used that.
It?
Yay!
How many do we have?
I think we're up one.
We're at currently 12.
We're at 12.
We need 3 more. Oh wait, no, we were going 12. We're good.
So how many times did you guys win?
More than you.
Sucker. How many?
7,
And how many did I win?
6.
Oh.
5, if we can do math, maybe.
I didn't
Silly
actually read it.
goose.
I was just like, what? Yeah.
So there, our experimental probability came out to be the same.
It could have been rigged though, so that it would. It's a digital.
What do you mean by rigged?
Like
Could have
they can
programmed
just
it to
make
do
it
this
so that
for
it
this
does it in a
time,
particular
this,
order,
that
and it's not
time.
actually random. Actually.
All right, so in that same vein, Sinclair draws this. She goes, you know, an area model seems kind of silly. I can just do this. And then I can more easily see it and if, and at and af. And then I can kind of quickly identify, okay, you're good, like you're cool, you're not. So this is a good result. This is a good result. And this is a good result, right?
Yeah, it's not a half probability though.
But why?
The conclusion's gonna be because you didn't take into account that I, U, and A are not equal, and P and F are not equal.
Could I
Silly
use
goose.
a model like this,
You could.
but modify it to reflect that?
Yeah.
If you put like above the layers, like this one has a certain percent chance of happening or a fraction, and then
I like it, but I have another idea, an even different modified idea that I think might work well. Different. Always got to be different. What did we say the probability of? Give me a letter.
W.
R.
Okay. Our first 3 letters on the first spinner were.
U.
I. A.
And what was our probabilities?
U was 1/6.
I was.
A half.
2 6.
1/3.
Oh yeah.
Or yeah. It doesn't matter though. Oh, because it's guaranteed.
So, as I look down, my first event that happens, something has to happen,
I
right?
love events.
So what do we know about these probabilities? They're going to sum to
1.
1, always.
100%.
So then event 2 was, wait, they weren't even.
It was C and F, but they weren't even. No.
So they were T and F, but what do we need to put there then?
But F, well,
T was 1/4 and F was
yeah,
the other, the 3/4.
3/4.
Yeah. The other amount that exists.
Yeah.
Yeah.
It seems like a lot of writing.
Yeah, this seems unnecessary.
Yeah.
Okay.
But maybe
I
I
hear
guess
you.
if it was a bigger problem, it could be more useful. Although it'd be more writing.
So then, if I want to say, because we didn't figure out, like, what's the probability of AF, right? We got AF a lot.
It's very probable.
Sorry, I almost took a wrong turn there. What's 2 6 times 3/4? Boom, done.
6 24ths?
Sure.
3 12ths?
Yeah,
That's
that's the probability of AF.
really not that probable.
0.25.
Ooh, that sounds like
Wait,
a little
that's
bit
the
more.
same number.
2 6 times
3 12ths is 1/4. And 0.25 is 1/4.
Okay, with you.
It's
Okay, so this would work to reflect the same thing that we saw from the area model, but instead of having the probability of the event in the area model, we'd probably write them out here, right? But at least then we could more easily see what the word is, right? Like it or at or whatever. Like,
Yeah.
yeah.
Words.
Okay, so we got a pet rat. My buddy in middle school actually did have a pet rat. Matt Jennings. Always found it interesting. He didn't just get a mouse, right? It's like, who gets a rat?
We had a rat in elementary
Did they name
school.
it Scabbers? Because then that would have been a Harry Potter.
Ha 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 ha.
So-
funny.
So, Ryan's got a pet rat. Actually, my friend Ryan does have a lot of different pets, but no rats. And they're arguing. So the rat's name is Romeo. And Sammy says, I don't really think Romeo's that smart.
Oh, that's mean.
I just think the rat chooses a random path along the maze. So, assuming that there's been no training going on, right? Sammy's arguing the maze is equally likely when it chooses a path. Now, let's assume the rat always moves forward, right? So, no going backwards, right? Assume the rat's always moving forward.
That's not really much of a maze then. It's just kind of like there.
So, he's put cheese into room A. Now, if the mouse learns, and this has been done like a lot of times, right? You've probably heard of things like this. If the mouse learns, its success rate should what? And like comparatively, what do you mean? Maybe I should stop talking and just ask you to say what we would investigate here. How could we figure out if Romeo's smart or not?
We could
measure the probability that, like, which room he would choose if he just chooses a random path.
Ooh, okay. Show Sammy. All right, if he just chooses randomly, this is his probability of success. And if Romeo is smart,
He'll start probably around that and then increase it.
yeah, he'll exceed it, right? At some point, either he'll start at right about what we would expect and then get better, or if Romeo's just smart from the beginning.
He'll just look straight forward to
Yeah,
see the
it's like,
room.
whoa.
Now they say he can't outsmell the cheese.
Oh.
And also, we assume that there are like gates or something, so yeah, he can't just see what's there. There's no nothing's that easy.
Okay.
So I want you guys to figure out what is the general, and actually, I want you to try this on your own for about 90 seconds at least first.
Like not as a
Can I come
key.
up and write on the board?
Not yet. What's the?
I need it to think like that.
No, what you need is paper.
That's true. I do need to.
Yeah.
This is factual.
I was waiting for natural consequences to cause you to get paper out. I was trying not to do the teacher thing and tell you you must have paper out. Try on your own first. What is his just general chance of success if he is not anything special, just an average rat?
Would have, like,
He is an average rat.
So we're assuming every gate is equally likely when we make that like choice.
Okay.
It's like how many gates are there at his first one? There's 3, right? There's top, center, and bottom gates.
I'm gonna draw a horrible.
I knew it was bigger.
That looks like a cat.
Now, how do I add these two? Okay.
There are 3 ways to get into room A, right?
And there's 3 ways
Wow.
to get into room B.
Like there are 3 entrances, yes. And yeah, there are 3 ways.
Can you go to room B and then go to A, or is
Nope.
it like okay?
The gates only go one way,
can't go
right?
back.
So you can't go back.
No, but like you could go to B and then turn around and then go straight and then there's A. Can you do that?
Like go in here and then back?
Yeah.
No, that's a wall.
Oh,
That's
okay.
Alright, let's start easy. Bad word.
Romeo es Mexico.
What is the chance of this blue path into A?
1/3.
1/3, right? Because there's only one gate to get there. So that's a 1/3. What about our green path? Let's go, Hilo Jake Rockshire, since you haven't.
1/3 times 1/3.
Oh, because this gate also has 3. This gate had 3. So the chance of going up here is 1/3 times 1/3 on this split. So 1/3 times 1/3 is 1/9.
And then the other one is 1/6.
And how'd you figure that out?
Because there's 2 ways to go through that one.
So 1/3.
It's about a 61% chance to get into room A.
So you said 1/6.
Yeah.
So we put all these together. We get, you said approximately 61. So that'd be like out of 100. Approximately, I should really squiggly these.
61 with the 1 repeating.
Yeah.
Okay.
Really, we could do common denominators. If you go to 18.
Yeah, it's 11/18.
Yeah, I was about to say this would be 2/18. This would be 6/18. And 3/18. Please ask if you have any confusion on how we got there, but I believe I've done this with you guys before.
So it's 11/18.
To 11/18. So, just generally speaking, what's his chances that he's going to be successful or not successful?
He's successful 61% of the time.
It's actually more likely that he's successful.
Yeah.
So, if Romeo claims, hey, he found the cheese more times than he didn't find the cheese, does that mean that Romeo's smart? What would we have to, what would we need to have happen to be
You
able
would
to,
need
like,
to exceed it.
exceed what?
The chance.
So, let's say to make our life easy, we run this trial 10 times. What?
Well, we should run it
We should
18
have
times or
'cause
36
we have-
times.
Ooh, okay. We should run 18 or 30. Let's say we run it 100 times, right? 100's a nice denominator. Say we run it 100 times, and Romeo finds the cheese 66 times. I swear it's on this screen somewhere. Yep.
This is it right there.
Is Romeo smart? I want each of you to make an argument.
I mean, he exceeded it by 5%.
Substantially.
Okay, you said, well, he exceeded by 5. You said not substantially.
It's not substantial enough to come to that conclusion. It could just be luck.
Actually, what could we do based off what Connor said? What could we do?
Run the trial 100 more times.
Well, you're a really good ventriloquist.
Yeah.
It 100% sounded like your voice came out of like that over there. Yeah, if we run this a bunch more times, either you could run another set of 100, right, and see does he outperform the first set of 100, or if we made our sample size like 1,000 or something like. Guys, this is what researchers do, right? And not necessarily with animals. If you want to be like PETA friend, yeah, but the rat's getting fed, getting cheese every time.
It's not like those experiments where they poke them and prod them. It's literally just here's a maze, go eat food.
If somebody came to you and they're like, all right, we're going to put you in a maze and you'll either not find food and go back in your home or find food, get a snack, and then go back in your home, I'd be like, yeah, okay, sign me up. Like, you're going to go back home. Like, the rat always goes back home. So Sammy is skeptical. Sammy's like, you know what, I think that's just a little bit, he's already set to win, right? Like, he has a better chance of finding the cheese than not finding the cheese just based off how that maze was made. So Sammy makes this maze.
Sammy's a doofus.
Oh, wow.
Sammy's a scammy, if you ask me. If Romeo really can learn, he ought to be able to figure out how to run this new maze I've designed.
Whoa, that's crazy.
To give Romeo the best chance of finding the cheese, in which room should we place the cheese?
So we're trying
We-
to help out.
We want to keep
B or
making
C?
Romeo look good.
B or C, but not A? Or can we choose A?
To give Romeo the best chance of finding the cheese, in which room should the cheese be placed?
I don't think the answer is A to
It, you have all options. A is the really big room, but that doesn't necessarily mean it has better chances. Yo, Connor.
No,
Sorry, that was a bad toss on my
that was
part.
a bad catch.
It It was just under. I threw over earlier and about hit a kid in the face.
Oh,
So
no.
Room D.
or D.
Yeah, put it in
Room
D.
D.
Climax. Wait, are we
Actually, the
working
chance of
together?
ending up in room D would be 0 if they have to run the maze.
Oh,
And
yeah.
there's no
you're
going
right.
backwards.
Silly goose.
Uh-oh. Wait, are we doing this as a group or individual?
Ah, you can do it as a group, sure.
Okay.
Feel allowed to think as a group.
I feel like this is a half, and this is a half. Can
Be
everyone
careful
agree?
where you're writing your fractions. Should we write our fractions at the gate or before we,
Ooh, wait.
like, should we write them at the gate or in the path, I guess is what I'm
Are
asking.
you looking at the highlighter?
Alright.
We could. No, I'm looking for the eraser.
That.
What we could do is we could write.
Here,
No, no.
hold on,
no,
let me make
no.
your life easier for a
There we
second.
go.
Erase your D,
Oh, well, it's
Erase your
great.
D,
It's so
and then
great.
don't do anything for a second.
Are you gonna take a picture and then
Are you bringing it into Photoshop? Or Paint? Yeah. Same difference. The E-N.
Notches.
Whoa! You got rid of the E-N. Amazing.
Thank you.
Alright, now this is real big to write on. There we go.
I'm just gonna solve it on my paper.
Wow, Jake.
Man, the kid who didn't have paper out at the beginning is now just saying, I'm just going to solve it on my paper.
And I think these are also one half down here, right?
Yeah, because there's that gate, and then there's another. You could change colors if you want to keep
Oh,
like
yeah,
things
yeah,
straight.
yeah,
Yeah, I mean, have like there was black gate, then there's red gate, or blue gate, or green gate, or water gate.
yeah. Watergate.
I am not a crook.
And then we can also have a
Watergate, the Nixon scandal.
Yeah.
You know what
Come
Watergate
on,
was?
Jake. I literally
You had a
looked
bunch
at
of
it
people
once, but-
like break into a government building and try to steal like a bunch of government records, and they got caught because somebody across the way saw dudes with flashlights inside the building. It's like some really silly story of like, yeah, you got caught. And then what went really famous was he was like giving a speech or coming off a plane or something, and he was like, I am not a crook.
Okay.
And he really was. Like,
Yeah.
he got in trouble.
There we go. Is that good?
Yeah.
Okay. And then, wait, we need green. These are also half, right?
Yeah.
So what we're really trying to figure out is if this is bigger than this, because these
Yeah.
are the same chance. Well,
Ooh,
or-
wait, we're saying B and C are the same chance?
well, no. We're saying that these two parts of B and C are the same chance. So
Okay,
we
but
need to see
not
if
that
these are-
rooms B and C are the same.
but there's also A. A also exists.
There are 2 ways to get into A, 2 ways to get into B, and 2 ways to get into C.
So C is more likely.
Let's go a way at a time. Let's just start at your top path.
So A.
What's the chance of being spit out that top path, that top gate, I guess if we call it, into room A? What's that chance up at the top of the diagram?
All right. So
Because I can't quite read your
33%.
handwriting.
A equals 2/3 top.
Wait, how 2/3? What?
It's 2/3 of the top.
Because if he chooses
Oh, we
either,
could do 2/6 to make it
Yeah.
more like.
Wait, is it 2/3 or
it's
2/6?
2/3 or 4/6.
It's two. It's two.
You could write with a
6.
thinner pen, by the way. When you click the pen, there are different sizes. That's what's happening. Is you're writing with a really thick.
That looks good.
So wait, is each gate 2/6 or together they are 2/6?
Each gate is 1/6 because it's 1/2 times.
Yeah.
30.
Okay, so do me a favor and jot a little 1/6 at the gate, like inside room A. Jot a little 1/6, and do it at the other gate too.
This one?
Yeah, because in total we need all of those to add up to be 100%,
Yeah.
right? Or like 6/6.
This is also a 6. Are they all a 6? I don't think that's true because this is a 4.
Oh, that's a fourth?
1/2 times half.
okay.
And these are code 8s.
I like that you're just like, that's a 4? Like, no, he means the 1/2 times the 1/2. I think he means the
Yeah.
path in is a 4.
Well, this one's also 1/8.
Oh, right.
We can do it.
Okay.
Yeah. And then, so it's A. 1/2 times 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/8. 1/
So wait, an eighth, an eighth, an eighth, an eighth, a sixth and a sixth add up to 1?
No. Wait.
An eighth, an eighth, an eighth, a sixth, a sixth, a sixth. Huh.
I think we need one more one.
We need one more eighth.
I think this is a 6. This is a 6, right?
Yeah, that's a six.
Okay, so yeah.
We need one more
A
eighth.
and B.
Where is the other eight? Wait. Oh, this is a fourth.
That's a 4th? Okay. Okay,
Yeah.
you know what? I'm sorry.
I was waiting for Roxanne to get annoyed.
No, that's stupid. It's fine. We can read it.
Yeah. Well, you can't read mine.
I'm not saying that.
Okay, but I'm just
Just
gonna
put it
rewrite
in
it
room
over
B.
here.
Jake thinks room B.
Jake thinks
He's working alone, whereas you guys have been working
Okay,
with each other.
1 6 plus 1 8 is. Wait, we should probably transition it to something close 6
It's a 14.
Man, common denominator? Who would think about that?
14 48
Think so. That makes sense.
This is my thinking.
Yeah.
times 7. Wait,
You
6
can
times
do-
7 is 48.
Wait, 6 times 7 is 42. Isn't that an 8?
Yeah.
It looks good. I'm waiting to see if you guys can all
Is
get
it
to a
No,
point
we're
of agreement.
calculating for.
Oh!
We're trying to put a common denominator so that it like
For 6 and
so that it looks nice.
Okay.
What's the common denominator of 6 and 8?
Denominator.
6 and 8?
Yeah.
48.
How?
Because you can split up.
8, 16, 24,
Oh,
48.
Oh, because it
24
multiplies by
works.
12. 24. Oh yeah. So well not 7. 2 6, which means. Well, okay, so wait.
Did you guys find your missing eighth?
So it's 2 6 times. Wait.
Two
It's 16 24?
Yes.
No.
No,
That's too high.
wait, no. The 8 24.
8 24?
Times 4 times 4, 8 24.
B equals.
Wait, is that the same as Jake got? Jake, did you get B?
Okay, wait, times.
I think Jake's wrong.
Oh,
Just like,
okay.
I
Do
wanna
you
say
just
it's
want
right
Jake to be
now.
wrong, or do you actually
I
think?
think-
No, honestly, I think he's wrong.
Okay, wait, no.
But didn't you just say B?
Times 4.
No, we're calculating all of them.
Ah.
Okay, times 4 times. Okay, I think it's 7.
This is 4 24, so this is
3 24.
8 24?
So
Okay.
7 24.
Well, we've already disproved Jake.
Okay, wow.
Uh-oh, Jake.
The-
Double check your calculation.
I'm right is the thing.
Oh,
Are you though?
I said it looks good. I didn't say who was right.
Oh, shoot.
Math can look good and not
Okay.
be
Okay,
right.
so 1 8 plus 1 4. I think it's C.
But I'm not saying you're wrong
Okay,
either.
24. So 8, 3.
Yeah.
3
I
plus
miscalculated
6 is
something.
9.
Sorry.
Wait, you miscalculated something?
Yeah, I typed it in wrong in my calculator.
Wait.
Ooh,
Does it add up? It doesn't.
calculator.
It's C. Yay.
It adds up.
It's the calculator's fault, Jake.
That's what I just heard Jake say. Is it's the
Oh,
calculator's
okay.
fault.
Well, it is.
Oh, never mind. We're good.
Wait a minute. So your
Now,
answer
which
was
one do you
right?
think, Jake?
Hold on. I am calculating it now.
Blocking it. You need to get like a big like.
No, like
blocker
those
to
things
get
that the
into-
teachers have. Like,
Yeah,
no
where
idea.
is that tool?
I don't know.
Is it this thing?
Screen shade? Yeah.
Yay!
You will never see
You
it
can
now.
change the color sometimes. I know they changed it, so I don't know how to.
That might
I
be
don't
a
know that you can
different
actually change the
application.
color of the screen shade. They might be using Google Slides though.
Google Slides.
I'm still stuck on my smartboard.
I like this
So
one.
I might be
I know it
using-
gives me all the math tools. Sorry, I'm trying to tie up another mask. My one mask broke.
Doesn't PowerPoint also have some math stuff? Or no? Is that a lie?
Probably. All right, so wait, are we good to talk about this together? Because we're running out of time.
I'm
Jake's
still calculating.
calculating.
Well, maybe the problem is that you're using a calculator.
Yeah.
Oh, let's just double check these live.
That's a C with the happy face on it. Just so you know.
So
Yeah, the room it has to be in is C happy facer.
let's
Oh,
check. Do
where-
we agree?
Does it go like?
Is this 1/2?
No, it
Yeah,
goes
yeah.
to C is the next one.
Yeah.
Is this 1/2 1/2 times 1/3 to make 1/6? Yeah, sure looks like it. Is this 1/2 times 1/3 to make 1/6?
Yeah.
Sure looks like it. Making this 2/6 or about 1/3?
Yeah.
About being
Oh,
actually.
yeah.
Is this 1/2 times 1/3? Yeah, because this was one of 3 choices.
Yeah.
So this is 1/6. Is this 1/2 times 1/2 times 1/2? Yeah, it is. Which gets 1/8.
Yay.
So 1/6 and 1/8 together.
Equals, if you look to the side of the
7/24.
board, 7/24.
And then my poster's gonna fall.
Yeah.
Is this 1/2 times 1/2? Yup, that's an easier route. 1/2, 1/2, 1/2. Another 1/4. So what are 2 1/4?
Half.
Yeah, 2/4 or 1/2.
Alright, so for
Even
room
though
A,
C looks the smallest, it is
No,
the most
that's
probable.
not right.
Didn't you say 1/2?
It's an eighth and a fourth. It's
Oh, an eighth and a fourth.
fourth and a fourth. Yeah.
So wait, what do we get? 3/8?
Yeah.
What would this have to be 3? Well, what? I'm asking a bad question.
9/8.
9/8, right? If this was 9/8, it'd be equal. 7/8 is definitely smaller. 7/24. So 9/24, if we want to talk about room C in 24,
Yeah.
versus 8/24, right? So if we were to rank them, it's room C, then room A, room B actually being the worst choice
Yeah.
here.
That's why I was surprised when Jake said B.
Yeah, I mistyped it, okay?
Calculators should not be trusted.
Yeah, they were wrong.
Calculators should
Yeah, I
not
got about
be trusted.
33% chance for room A, 33.3 room A, 29.2 for room B, and 37.5 for room C.
So we should hang out for just a couple minutes to give Perry time to get out of lunch, because we're trying to not head down there till 12:18. It looks like Mr. Hall's room is going, but you guys want a riddle?
I'd like to say, if calculators can't be trusted, why does the school make us buy like $3 billion calculators?
Yeah.
No, the problem is you need your calculator to do the hard calculations, but you shouldn't just blindly trust your calculator. You have to double check that you've typed things in right.
Yeah, I always
So it's not the calculator's fault.
Yeah, I'm always a silly goose, and I
You should fix
your.
your poster when
Wait,
you're
how
done
much
with
time
your
do we
notes.
have?
Like a minute. I mean, people are already moving in the halls, so the biggest thing is don't rush down to lunch. Give them some
I
time
walk at normal.
to get out of there. Yeah, but other people don't.
Everyone else's fault if they're walking slower than me.
If they're walking slower than you,
Or if they're walking faster. I just am the normal pace setter. That's facts.
I'm gonna play a math game.
Is it slow?
Yeah.
Yeah, it totally has to do with life.
Oh, yeah, that game. People are
It's fun. It's math. So slow.
What's your high score?
I think 75.
That's math. It's a number.
Numbers! Yeah, let's go. Math.
Any game that has numbers is a math game.
Pretty true.
I mean, I could probably argue everything is math.
Mr. Hudson,
You should fix your
why do you have a curse word on your
complementary and
poster?
supplementary.
Why do I have a what?
A curse word on your poster.
I know, I covered it up on the one poster.
Ah. That's what I mean.
Here, Connor. I empower you.
Oh! Sword!
Fix the triangle
Take
one,
this.
the
It's
pink one.
dangerous to go alone.
Yeah, okay, good job.
Are you playing Zelda?
I was about to say, wait a minute, take this, it's dangerous to go alone. I know that.
Okay.
Alright, we should go to lunch.
Thank you.
Have a wonderful day, guys. Thank you. I was about to say, you can't take that with you. It's not like yours forever.
Oh, dang it.
I
I
remember when
wanted
you
this
gave
one.
Connor the ruler.
What?
The
Oh.
I get it now.
Well, he's not going alone. He's got us.
What? We don't really count. Myers Hudson.
All right, Jake, have a great day.